Okay, so our lesson that is on derivative of logarithmic and exponential functions. So the formula that we will be using here, we have derivative of log of u base a, that is equal to 1 over u ln of a du dx. If we have log of u base 10, derivative for that is 1 over u log of e base 10 du dx. Okay, that one. So we have derivative of ln of u, that is 1 over u du dx. Derivative of a to the u, so we will have a to the u ln of a du dx. Okay, another formula that we will be using, that is derivative of e to the u, which is equivalent to e to the u du dx. So our first example, we are going to find y is equal to e sine 3x. If we're going to look at here, this is a form of e to the u, wherein our u, that is sine 3x. So to solve this one, we have dy dx is equal to d dx of e sine 3x. So from the formula, if we are going to have a form of e to the u, we will have e to the u du dx. So e to the u. So we have e to the u, derivative of u, wherein our u, that is equivalent to sine 3x. So that's the reason we'll have derivative of sine 3x. So we will have e to the sine 3x, derivative of sine, that is equivalent to cosine. So cosine 3x, derivative of 3x, that is 3. So we have that form. But never multiply 3 with your 3x. 3 is not part of 3x because 3x here, that is u. So therefore, you write first 3 here. So 3 e to the sine 3x cosine 3x. That is now the answer. The next example, that is y is equal to 4x squared plus 5. So we are going to find dy dx here. So if you are going to look at here, 4 is a constant. So that is a constant raised to a variable. So therefore, we have, that is from the formula, d dx of what formula? That is a to the u. So you will have a to the u, a constant raised to u. So therefore, you will have a to the u ln of a du dx. So that is the formula that we are going to use. So therefore, solution here, dy over dx, that is d dx of 4x squared plus 5. So if you are going to look at here, our u here, that is this one. This is our u. So therefore, we will have formula a to the u. So just write it again, 4x squared plus 5. Okay, that is a to the u. ln of a. What is a? 4. Next, derivative of du dx. What is our u? X squared plus 5. So x squared plus 5. What is the derivative of x squared? That is 2x. Derivative of 5, that is 0. So 2x, so you will have 2x. 4 x squared plus 5 ln of 4. This is now the answer. So the next example, we have q is equal to 4.84 e raised to negative 0.2 t. We are going to find dq over dt. So from the formula that we have discussed a while ago, we have the derivative of e to the u, that is equal to e to the u du dx. So this is a form of e to the u. In this example, we have our variable is t with respect to time. So we have here the derivative of q with respect to time. So we have derivative of 4.84 e raised to negative 0.2 t. So 4.84, that is constant, so you bring that out. 4.84 ddt of e negative 0.2 t. So if we are going to look at here, our u, so this is our u. Our u is negative 0.2 t. So therefore, from the formula, we have 4.84 derivative of e to the u. Formula states that we have a to the u du dx. So we will have e negative 0.2 t e to the u. Derivative of u d dt of 0.2 t. This negative. Okay. Derivative of negative 0.2 t, that is equivalent to 0.2 negative. So 0.2 times 4.84, that is equal to negative 0.968 e negative 0.2 t. Okay, that's the answer. So you will have 0 here. So this is now our dq over dt. So this is now the final answer. Okay, the next example, we have y is equal to ln 1 minus cosine x. We are going to find dy dx. So from the formula, d dx of ln of u, that is equivalent to 1 over u du dx. So therefore, dy over dx, that is d dx of ln 1 minus cosine x. So we will have ln of 1 minus cosine x. Our u here, that is equal to 1 minus cosine x. That is our u. So we have a form of ln of u. So if we have a form of ln of u, the formula then, that is equal to derivative of ln of u, that is equivalent to 1 over u du dx. So therefore, we have 1 over, okay, 1 minus cosine x. Derivative of d dx of u. What is our u? 1 minus cosine x. So you will have 1 minus cosine x. Okay, so we have here derivative of 1, that is 0. Derivative of cosine, that is negative sign. But then we have negative here. So therefore, we have positive sine x over 1 minus cosine x. Why we have positive sine x? Because derivative of cosine x, that is equivalent to negative sine x. Then we have negative outside. So that's the reason that would become positive sine x. So where is 1 now? Derivative of 1, that is equal to 0. So therefore, our final answer, that is equal to sine over 1 minus cosine x. So that is now our final answer. Next example, that is y, that is equal to log of x cubed plus 4 base 10. So from the formula, we have derivative of log of u base 10, that is equal to log of e base 10, 1 over u du dx. So solution here, we have d dx of y, that is d dx of log of x cubed plus 4 base 10. So therefore, we have, from our formula, we have 1 over u. What is our u here? Okay. Our u here, that is x cubed plus 4. So we will have, so this one is our u. So therefore, we have 1 over u. So 1 over x cubed plus 4. Okay. Then we will have log of 10, log of e base 10. Then we will have derivative of, what is our u? X cubed plus 4. Okay. X cubed plus 4. So therefore, what is the derivative of x cubed? That is 3x squared. What is the derivative of 4? That is 0. So therefore, we will have x cubed. So we will have 3x squared over x cubed plus 4 log of e base 10. That is dy over dx. That is now the final answer. Okay, the next example, we have y is equal to log of x squared minus x plus 1. That is base 3. So, a while ago, our example, that was base 10. Okay, take note for that. So, if we will have a different base, that is not base 10, so we will be using this one. ddx of log of u base a, that is 1 over u ln of a du dx. Okay, solution, we have dy dx, that is ddx of log of x squared minus x plus 1 base 3. So therefore, we will have formula, we will have 1 over u. So what is our u? Our u here, this one is our u. So over u is equal to x squared minus x plus 1. So therefore, we will have 1 over u. That is x squared minus x plus 1. Okay. Then we have 1 over ln of a. So we will have 1 over ln of 3. Our a is equal to 3. Then derivative of d dx of u. That is, our u is equal to x squared minus x plus 1. Okay. What is the derivative of x squared? That is 2x. What is the derivative of x? That is 1. What is the derivative of 1? That is 0. So therefore, we will have the answer then, that is equal to 2x minus 1. Derivative of x squared, 2x. Derivative of negative x, negative 1. Derivative of 1, 0. All over, okay, ln of 3 times x squared minus x plus 1. So, our final answer, that is equal to dy dx, that is equal to 2x minus 1 over ln of 3, x squared minus x plus 1. Example, we have y is equal to x raised to x squared. So, if we are going to look at here, we have a variable raised to a variable. So, therefore, what we're going to do with this one? So, when we have that form, y is equal to x raised to x squared, okay. To solve this one, we are going to multiply both sides by natural logarithm, that is ln. So, we will have natural logarithm of y multiply ln inside. So, we will have natural logarithm of x raised to x squared. Okay. So, from the definition, from our algebra, we have, if we will have ln of a raised to x, that could be expressed as x ln of a. So, that's the reason we will have ln of y equal to x squared ln of x. Then, after that one, we have that form. Find the derivative both sides. That is d dx. Okay. If we are going to look at here, we can find the derivative of x squared. We can find the derivative of ln of x. So, that is now derivative of a product. So, we have d dx of ln of y, d dx of x squared, ln of x. So, try to look at this one. You can find the derivative of x squared. You can also find the derivative of ln of x. So, if you can find the derivative of x squared, and you can find the derivative of ln of x, then that is a product. Okay. So, proceed to derivative of ln of y, that is equivalent to, what is the derivative of ln of u? Derivative of ln of u, d dx of ln of u, that is equivalent to 1 over u du over dx. So, therefore, we will have 1 over y dy dx. Okay. Then this one, this is now product. So therefore, you will have x squared d dx of ln of x. Then we have plus ln of x d dx of x squared. Okay. We have that form. So from that, we will have 1 over y. Then we will have dy over dx. Then we will have x squared derivative of ln of u. What is derivative of ln of x? So derivative of ln of u, that is 1 over u du dx. So we will have derivative of ln of x, that is 1 over x, okay, d dx of x. Okay. Then we will have ln of x, derivative of x squared, that is 2x. So, but never multiply 2x with x. That is not part of x. So, to simplify that further, we have 1 over y. Okay. You will have dy over dx. Dx over dx, that is cancelled out. Okay. So, that's the reason we'll have x squared over x. That is x. So, we will have x. Okay. Did you understand why we have x only? Because dx over dx cancelled out. You have x squared over x, that is x. So that's the reason we have x here. Plus 2x ln of x. So therefore, we have dy over dx, that is equal to, cross multiply. We will have y. Okay. Cross multiplication. Y. What is common here? What is common? X, X. So, you will have X, Y. Right? The common here is X. X, X. If we are going to factor X, what will happen? Inside, we will have 1. If we factor X here, ano sa mabilin? We have 2. Then, we will have ln of X. Okay. So, dy dx, that is equal to, what is y equivalent to from our given? Y is equal to x raised to x squared. So, we will have x raised to x squared. We will have 1 plus 2 ln of x. So, we have, so where did you get x raised to x squared? That is from y. From here, given y is equal to x raised to x squared. So therefore, our final answer, that is equal to dy over dx, that is equal to, we have the same basis, different exponent. So therefore, we will have, your exponent here is 1. So if you will have the same basis, different exponent, from our algebra, we will have, what you're going to do from algebra, am, an. So the same basis, different exponent, you are going to add the exponent a m plus n. So here we have an exponent of 1. So that's the reason you will have x raised to, what is your exponent here? 1. 1 plus x squared. Okay. Times 1 plus 2 ln of x. So that is now the final answer. Okay, so we have here our practice problems. So kindly answer this one and then pass the answer to our Google class. Okay?